Since Egypt was on the Nile River, they would it would overflow, and people's land borders would get sort of wiped away. So a lot of people say that this is part of the reason why in Egypt they did and invented a lot of formulas for area in geometry. And we see in the Rhine Mathematical Papyrus, Rhine Papyrus is about 80 questions, and starting around question 40, 41, the last, like almost half of the questions in it are geometry questions. So one thing I want to show you is that they did have the formula for the area of a rectangle is base times height. We can see that in problem 49. What is the area of a rectangle? That's 10 by 1. And they have some units of measurement, but basically they are multiplying the numbers together. They also knew the formula for area of a triangle is base times height over 2. We can see here in problem 51, they're trying to find, here if you take a look at this question 51, you see they're talking about a triangle that's 10 by 4. And it looks like here they say half of 4. It says half of 4 to get its rectangle. That seems to mean that if I have like 10 and the height is 4, they're kind of saying that they know that if I made a rectangle that was 10 by 2, it would have the same area as the triangle that's 10 by 4. And then they say multiply 10 times 2. I'm not sure what all this stuff is. They know back then that the area of a trapezoid is base 1 plus base 2 over 2 times the height. There's our trapezoid. If you look back at question 52, they call it a cut-off, truncated triangle of land, but they are talking about a trapezoid. 20 is its side, 60 is its base, and 4 is its cut-off line. That's their way of saying this, apparently. And they say that to add its base to its cutoff line, so 6 plus 4 is 10. Then they say to divide by 2 to get 5, to get its rectangle, and then multiply 20 times 5 to get 100. One really important problem in the Rhine Papyrus is problem number 50. It says here, a round field of diameter 9, what is its area? So in modern day, they're saying that if the diameter is 9, well, in modern day terminology, area is pi r squared, which is pi times 9 over 2 squared, which is 81 over 4 pi, which is approximately 63.59. That's what we know today. However, back then they got a different answer. Sorry, 63.59 is what we get today. Well, they didn't get 63.59. they got something a little bit off from that. And let's see, based on the Rhine Papyrus, what their algorithm might be. It says here, take away half the diameter. Sorry, take away 1/9 the diameter, namely 1, and the remainder is 8. Multiply 8 times 8, it makes 64. So this suggests that their algorithm is x minus x over 9 squared. Where x, can I call it d minus d over 9? That's their formula for area of a circle. So this one, unlike the other formulas, d minus d over 9 squared. So that's the first formula that's not like correct in that it doesn't get us the exact answer. But it gets us a pretty close answer, because in this case 9 minus 9 over 9 squared is 8 squared is 64 versus the actual answer of 63.585 approximately. How close is it? Well, it's only off by about 0.6%. Some people go on to say that that means that they had some approximation of pi that was off by 0.6%. They did not have an approximation of pi. They had a formula for the area of a circle, which was pretty good approximation, d minus d over 9 squared. Now, you might wonder, how did they come up with that formula? Well, I've seen two theories about this. One is that if you had this picture here, I have a 3x3 grid, and this shape here, which is like some kind of octagon, although not a regular octagon, it has an area of 1, 2, 3, 4, 5. These two together make 6. These together make 7. And, well, 7 3x3 grids, which is 63. But you see how the circle kind of goes outside that thing a little bit. It also goes under it. But one speculation is that it's kind of close to that picture. But to me, the more compelling argument that I've heard is that if you were to take 6 circles, and you could do this with like pennies. That's not the best picture of it. If you take 7 perfect circles, you put one in the middle, you can kind of make a picture like that. Now, this thing, if I were to draw like a line across the middle, these 7 pennies are kind of like the area of a circle. This thing is not a circle, this flower-shaped thing, but its diameter is 3, because you see 1, 2, 3. So if you think that this thing is kind of like a circle, these 7 circles together, you can say that the area, that 7 is the area, approximately, when the diameter is equal to 3. So a formula you can kind of create is maybe it's d squared, which would give me 9, times 7 over 9. That would be a formula that, at least if I put 3 in for the diameter, I would get 7 as the area. But that formula wouldn't be like so accurate, because that would mean if the diameter equals 3, the area equals 7, when the real area would be pi, which is about 3.14, times 1.5 squared, which is about 7.065, which is actually pretty close. This formula here would be off by about 1%. So this formula is not bad, but the formula that they use is, well, if I take this, if I do d minus d over 9, it would be 9d over 9 minus 1d over 9, 8/9 d squared. That's kind of their formula. And that's even better than 7/9 d squared, 8/9 d squared. So how'd they come up with it? Well, there is a speculation that, yes, if you take 7 pennies, you can make a sort of hexagon-looking thing out of it. But if you try to make a bigger thing, and this is just speculation, there's a lot of mystery about this, but see this picture here? If you take 64 circles, you can assemble them into a thing like this. So that suggests that the area of this circle that has diameter 9 and it has area of 64. So to make that happen, to make an area of, to make a diameter of 9 have an area of 64, you'd have to do diameter squared, which would be 81, but I want it to be 64, so it's times 64 over 81. In other words, 8 over 9, whoops. In other words, that's the equivalent to 8 over 9 d squared, which is the same thing as d minus d over 9 squared. That's the formula that they use, d minus d over 9 squared. Again, this doesn't mean, I've seen people say, oh, this means they thought pi was equal to 3.16, different things like that. No, they didn't think about pi the way we think about it today. They had a formula for area. It's a very nice formula because it's only off by 0.6%, and we have to give them credit for that, though not credit for inventing pi. The ordering in the questions of the Rhine Papyrus is not like the same order that I would put them in, so that's why these sort of jump around. Problem 44 shows that they knew that the volume of a rectangular prism, like a box, they were aware that it was length times width times height. And problem 41 is real interesting, because in this one, they're doing the volume, of a cylinder. And you see here, take away 1/9 of 9, namely 1, the remainder is 8, multiply 8 times 8. So this cylinder they're talking about has diameter 9, like the circle from problem 50. You would think they would put problem 50 before problem 41, but they didn't. And their formula for the volume of a cylinder is basically 8/9 d squared. That's like their version of pi r squared times the height. So their volume for a rectangular prism is exactly right, whereas this one is going to be off by 0.6%. Now, the most unfamiliar set of questions in the Rhine Papyrus is where they have a question about a pyramid, and they tell us how high it is and the side of its base. And they ask for a very unfamiliar term. What is its, I don't even know how to pronounce it, but I say second. So let's see what they're talking about. We can see that the answer is 5 1/25 palms. But what does that even mean? Well, let's take a look based on the information we have here. And they tell us what their process is. So they say it's 250. So here's our pyramid. I'll make a cross section of it. and they say it's 250 high, so that's this, and it's 360, that's its base. And they have this mysterious second, and the answer is 5 and 1/25. Well, to get this answer of 5 and 1/25, they say first take half of 360, which is 180. Notice how that 180 is the length if I were to make like a right triangle here. And then it says multiply 250 as to get 180. So they're saying 250 times what equals 180. In other words, divide 180 divided by 250. Now, if you want to use Egyptian division, you would say 250. I'm trying to get to 180, so I have to go half is 125. And since we can kind of see the answer already, we're going to cheat a little bit and just jump to 1/5, because that's what they use. 1/5 is 50, and that means these two together are already 175. So I need 5 more, which I can get by doing 1/50 and 5. So that's where they get the 1/2, 1/5, 1/50. Now that number as a decimal is 0.72. Now, what does that even mean? That they are going to multiply by 7, but let's not look at that just yet. That number is, see, that number was 180 divided by 250. If instead it was like a taller pyramid, and it was just 100 and 250, that would be like a smaller number then. So what this 0.72 is, it's related to, it's kind of like the slope. Although it's like 1 over the slope, because slope is rise over run. Like 250 over 180 would be the actual slope of this line, and 250 over 100 would have a bigger slope. But this one, they're doing 180 over 250, so the bigger the number, the more shallow the slope. Basically, it's like related to that angle there. Now, they then do a mysterious thing where they multiply the answer they have by 7, and they show the work here. And they get 5 and 1/25. So you might wonder, like, what is that 5? Like, why change to that? Why not just deal with this number and say, well, that's related to, like, the smaller it is, the steeper the pyramid is. Well, the 5 and 1/25 basically means that if I were to make like a right triangle with 7, maybe I should make this other one smaller because it is smaller. If that's 7 and I go 5 and 1/25 this way, it tells me how to create a triangle so that the hypotenuse would have the same slope as the slope of the side of the pyramid. So the bigger the second is, the bigger this bottom side is. 7 is still going to be the upright side of this sort of reference triangle. So a second of 10 would be a more narrow. So they measure it, and back then they would know like a second of 7 would be kind of like a 45-degree angle. Whereas a second of 5 and 1/25 would be more of a steeper thing, and a second of 10 would be more like that way. You probably would like to have a formula for second because it is pretty confusing. It's not a thing that we're familiar with. So I will tell you the formula is 1/2 b over h times 7. Now we can apply that to other questions. See in problem 57, they tell us that the second is 5 palms and 1 finger. They have this, I think 1 finger is 1/4 of a palm. And the side is 140. So we can use this formula, second equals 1/2 base over height times 7. They're telling us the second is 5 and 1 finger, just like in a palm. Would have sort of 4 fingers in there. I think a finger is 1/4. So they're telling us the second is 5 and 1/4. Oh, notice it says per cubit. So they are saying it's like a rate. And the side of its base is 140. And we don't know what its height is. So if I multiply both sides by h, and I work this out, becomes 490. The height's going to be whatever 490 divided by 5 and 1/4 is. And they ended up getting 93 1/3. You can see that they first took the second and doubled it. They basically multiplied both sides by 2 right away to get rid of that half. So you see it was 10 1/2. So 10 1/2, that does imply that this was basically saying 5 1/4. When you look at their actual calculation, their first step is to divide 1 cubit by the second doubled, which is 10 1/2. So what they did was they actually multiplied both sides by 2, and that became 10 1/2. Yes, that means that it was 5 1/4. A finger is 1/4 of a palm. And then the base was 140, so they already knew that. Then they say multiply 10 1/2 so as to get 7. That's basically their way of saying divide by 7. Anyway, just wanted to show you what second was, because that in the Rhine Papyrus, that's the one thing in the whole Rhine Papyrus that's not familiar to us as far as like geometry goes. But it's basically, second is kind of like 1 over slope, but then they times it by 7 just to make it in some kind of unit that they are able to relate to. For the work here, they did 5 1/4 times 2 is 10 1/2. Then they did 7 divided by 10 1/2 and got 2/3. And then finally they did 2/3 times 140 to get 93 1/3. That's because second is 1/2 base over h times 7. I can say 2s equals base over h times 7. Base over height equals 2s over 7. And that's, or we can do h over b equals 7 over 2s. Either way, I think they did it the second way. And that's where the division happened. But then they multiplied by the base to get the actual height. If I multiply both sides by base, these cancel out. So height is 7 over 2s times b. That's exactly what happened. They did 2s, they did 7 over 2s, and then they did times b. Okay, so that's going to do it for their geometry. As we can see, they were very sophisticated with it. They had area of a rectangle correct, area of a triangle correct, area of a trapezoid correct. Area of a circle was close, 8/9 D, and then squared. Area of a cylinder was close also. Area of a rectangular prism was correct. And then they had this unusual second where it's kind of like it's the reciprocal of the slope, sort of. The bigger it is, the shallower the pyramid is.